In this video we're going to go through section 10.4 in the textbook, and this goes through and does an example using the flight delay data set for logistic regression, and it has several different figures, plots, graphs, those sorts of things, and then there's some running commentary. So I'm not going to go into the commentary, but I will show you how to produce the figures from the text using JMP. So first of all, we're going to open up the flight delays logistic regression data set, and we're going to go in here to delay, go to column information, and then change the modeling type to continuous. We're going to need to do that just to make these plots. We're going to change it back to nominal in a few minutes. Notice that the value ordering is set so that 1 is first and then 0, and if it weren't that way we would need to set that. So we're going to come over here to tables, and this is to make figure 10.9. We're going to go summary, and we're going to say delayed statistics mean, and then we want carrier as our group, and when we say OK, we now have the proportion of the CO carriers that are delayed, and the proportion of DH flights that are delayed is 24%, so forth. So we can now make a plot of this by putting carrier down here in the X, and delayed, mean delayed, we'll put that right here, and then make it a bar chart. And we have the exact same figure then as the top left panel of figure 10.9. Okay, so to get the other ones, we're going to come back to flight delays, and we're going to do tables, summary, delayed again. Let's just push recall. We can get rid of this one and then throw in the next one, which is destination. Put that as group. Say OK. And now we want a plot of that. So we do the same thing. Destination is our X, and mean of the delayed is our Y. Make it a bar chart. And we get exactly the same thing as the top middle panel on figure 10.9. So if we repeat these things, we can do the same for the rest of them. I'll just do one more. Come back here and we'll go tables, summary. Let's recall that, remove the destination, and let's do day of week. So put day of week in there for the group, say OK. And now we can look at the chart. Day of week down here, mean of the delay here, and a bar chart. And we can see here that 1 and 7, just like in the textbook, we're told that these are about the same. So at some point we're going to actually group those together, and then we'll group the rest of these as a different group, or leave those ungrouped. And so that's figure 10.9. And in the steps in the textbook it says data pre-processing, what we need to do. Well, we did that already, and we came in here and changed delayed to continuous. Now in order to run the regression, we're going to need to put it back to nominal. Actually, we're not quite to that point because we want to make a heat map in figure 10.10. And for this one, we're going to do almost the same thing. We're going to go to tables, summary, and we're going to say delayed. We still want the mean, but now we're told to use carrier, day of week, and origin, and we're going to do that all at once. We're going to get cross interactions between these things, cross terms, intersections, whatever you want to call it. We're going to say OK. And so now we're going to go and to use the graph builder, we want origin down here, we want carrier down here, So it says carrier origin slash carrier, and then we want day of week here. So you can think of this as a, I guess in some ways, a four-dimensional map, heat map. And then we're going to take mean of the delayed variable and put it right down here in frequency, and then change this to heat map. And that gives us the same output as figure 10.10. And it looks like they're saying when BWI is the departure for the airline RU, and it's the 7th day of the week, that has a very high proportion of flights that are late. So whatever day that is from that destination and that carrier, so that airline would look at this, or the air traffic control tower would look at this and say, okay, these guys are always late and we need to do something about it. Okay, so we're going to go back to the data then, and we're going to change delayed from continuous back to nominal. Say OK. And now we want to fit the regression model for destination being the only x variable. And so we're going to go to Analyze, Fit Model, delayed is our y, destination is our x. And notice up here it says nominal logistic regression shows up. There are other options, but it recognizes the type of data that's being put in here and says that's the best one, let's go ahead and do that. There are other ways of running logistic regression inside of JMP. But what do we see? Come down here and we see the same as figure 10.11, and we get the same estimates, standard errors, chi-squared, and probabilities associated with these. So I will leave you to look at the textbook to see how to interpret all of these things, and we'll move on and try and come up with figure 10.12 now. To get that figure, we're going to go up here to the little red triangle and say, let's save the probability formula, and we see that we got line 1, ln 1, probability 1, probability 0, most likely delayed. And so if we just double click here or right click and get column info, we will see that here is the formula that's given in figure 10.12. The next thing they do in that section is fit the model with all of the variables. So we're going to go over here, Analyze, Fit Model. We're going to put delayed in here, and we're going to say carrier down here through weather, and we're going to add that in. And then we're also, in addition to that, going to use validation as our validation data set, or validation column, to tell us what the partition is. That we didn't actually do, that was done for us. And so we'll say run. And now we should get the same output as what's given in figure 10.13. And it looks like we do have that matched up here. So if we want to look at figure 10.14, that's the profiler. So we're going to just come here and click on profiler, and we'll see the profiler shows up again, figure 10.14. We also get figure 10.15. That's this whole model test, and we come down here and we see on the training data set the misclassification rate is 16.12%. On the validation it's 15.57%. And then to get figure 10.16, we just need to add in the confusion matrix and the lift chart. So we'll go confusion matrix first. There's a confusion matrix that matches up, and then we'll add the lift chart or lift curve, and that matches up as well with what we have in figure 10.16. For the variable selection subsection in 10.4, we're told that origin is not really that good of a predictor variable for various reasons that I'll refer you to the book you can check out. So we're going to run this again, but we're going to take out the origin variable. We'll run that, and we see figure 10.17 right here. Notice that destination has a p-value of 0.84, which says that really is not that informative. It's not something that we want to include in the model. And there are other things that they decide that should be good to group together in terms of days of the week. For example, Monday and Sunday have roughly the same proportion, so we could group those together. And then departure time and carrier also have groups that could be combined together. So we will do that. So we're going to do it for day of the week first. This is figure 10.18, and we're going to highlight the column just by clicking here and then go columns, utilities, recode, and then we're going to say number 1 is Sunday / Monday. We'll copy that, paste it down here as well. And it asks me if I want to convert this to a character variable. So I'll say yes, and then I want to change that also to Monday, and then the rest of these I'm going to put as other. Now we could just leave them if we wanted to keep them separated, but figure 10.18 says not to do that. And then we can say done. We want to do it right where it's at, write it over it, or make a new column, or make a new formula. We'll make a new column, and we'll see here day of week 2. So other, a lot of others. Here we get a bunch of Sundays, Mondays. To continue what they're doing in the textbook, we need to condense the carrier variable and departure time variable. So we'll click on carrier, columns, utilities, recode, and we're going to put in co/dh/mq/ru, and we're going to put that in for those 4 variables. And for these other ones, we're just going to put other. And then we'll say, let's put it in a new column. So that gives us our carrier 2. So now we've got 2 groups. And finally, based on the output in figure 10.19, we're going to change the departure times by going utilities, recode, and now we want anything before 9:59 to be low-959. So we'll copy that. And then this is where maybe there's a little bit of confusion. We have 1150 up to 1459, and we have this right here, which is 11 to 1159. So I think what we'll do is we'll put this as 10 to 1159, and then we'll copy that and paste it here. So we'll combine those into one group, and then here we'll go 1159 or 12 up to 1459. I guess we'll go with 1159 up to 1459. So we'll copy that, paste it there, paste it there. And then we would have 1459 up to 1859, and paste that in. finally we'll have 1859 through high. And we'll make a new column for that one. And we'll just look at the column info here to make sure that we have it so that it's going to output the same way as what we see in the textbook. So we'll do value order. We actually want this one to be at the top, and we want this one to be at the bottom. Whatever one is last is going to be the reference value or reference category. So we say OK. And now let's go run our regression model again. We're going to say delayed is our y variable, validation is our validation variable. We want weather. We want carrier 2, first day of the week 2, carrier 2, and departure time 2. And then we'll say run, and we'll see that we get values for our regression output that are very similar, although maybe not exactly the same as what we had. It was what is in the textbook, and that probably is due to the fact that when I made this departure time from 11:59 up to, or rather the one from 11:50 up to 14:59, I didn't get it exactly the same as what they had in the text. But nonetheless, these are very similar. If we look at the classification or the misclassification rates on the training and the validation set, we see that we get almost the same thing. We do get the same one for the validation. The training is very close, 18.62%. And so then to get the rest of figure 1019, we just need to add the confusion matrix and the lift curve. And then to get figure 1020, we need to add the profiler. And you see one row here. This is the top row in figure 1020. To get the bottom row, all we have to do is click on that point right there, and it says if we shift from this group, the CODHMQRU, to the other group, then the probability goes from 13.9% being late, given everything else being held equal, goes down to 4.1%. So that is everything we've got in section 10.4. Hopefully that will help you with this week's homework, and we'll see you in the next video whenever that may be.